Hi everyone, today we're going to look at how we can use the Pythagorean theorem to find the length of a hypotenuse of a right-angled triangle. We'll begin by looking at a diagram and seeing if we can make some observations about it. Do you notice that in the middle of the diagram there is a gray right-angled triangle? That is used to draw some squares on each of the side lengths. You'll notice that the longest side has a length of 5 and therefore has a square area of 25. The small blue side has a length of 3, and as a result, it has an area in the square of 9. And finally, the medium-sized side, the side with a length of 4, will have a side square of 4 times 4, or 16. In a right-angled triangle, there are some interesting properties that we can observe. In this case, if we look at the blue square with 9 and the green square with 16, if we added those two sides together, we would get 25. And that happens to be the number of squares in the longer side. This means that we can make a conclusion to say 3 squared plus 4 squared equals 5 squared. This relationship is known as the Pythagorean theorem, and it works for all right-angled triangles. So let's summarize with some vocabulary about the Pythagorean theorem. First of all, in a right-angled triangle, the hypotenuse is always the longest side. The hypotenuse is the side across from the right angle. A right angle is 90 degrees. The other two sides of a right-angled triangle are called the legs of the triangle. The legs are always shorter than the hypotenuse. The Pythagorean theorem tells us that the hypotenuse squared is equal to the leg squared plus the other leg squared. Now let's look at how we'll show our steps as we try to find the hypotenuse using the Pythagorean theorem. We'll begin by labeling our sides. The side across from the right angle, or the longest side, will be the hypotenuse. The other two sides will be the legs. The Pythagorean theorem tells us that the hypotenuse squared is equal to the leg squared plus the other leg squared. So in this case, we'll have c squared for the hypotenuse is equal to 6 squared for one of the legs plus 8 squared for the other leg. Now we'll expand this. C squared will leave as it is. We'll take 6 squared and know that that is 6 times 6, or 36. And then we'll do 8 squared, or 8 times 8, which is 64. We can simplify this further to say that c squared is equal to 100. Now, we know that the square on the side of c, or c squared, would have an area of 100. But we don't want to know what the area of that square is. We want to know what the side length is. So we'll need to think what number times itself will give us 100. We can use the square root button on our calculator to figure this out generally, but in this case, we know that 10 times 10 is equal to 100. So c is equal to the square root of 100, or 10. You might want to pause the video here to take a screen capture, or to copy down this example so that you have it for future reference.